Hi everyone. In this session, I am going to solve the game theory problem by uh, dominance principle. So here it is the game, and here the player A is having two strategies A1 and A2, and player B is having the three strategies B1, B2, B3. So here I want to discuss about a special case of the dominance principle. So that's why I am not checking the saddle point for this problem. So now let us see how to solve this by dominance principle. So here it is a 2 by 3 matrix. Already 2, if you want to solve the game any method by any method, the minimum order of the game should be 2 by 2 if you reduce it. So or if the game is having a saddle point in the further cases, then we can solve it by completely dominance method. So that is a special case. We will see if it is having a saddle point. So here it is, there are two rows and three columns are there. First of all, let us convert the three columns problem into a two columns problem. So now let us see. So here already two rows are there, so that's why I'm not checking going for row dominance. Or if you go for row dominance also, let us see. So now compare the rows 1 and 2, A1 and A2. If you compare, 8, 3, A1 is higher. 15 minus 1, A1 is higher. 1, 4, A2 is higher. So none of the row is not dominating another row. So that's why row dominance will not work out. So now let us go for column dominance. Now take a combination of the columns B1, B2 and compare the values of B1 and B2. 8, 15. 15 is higher. That means B2 is higher. 3 minus 1. B1 is higher. So none of the column is not dominating another one. This combination will not work out. Then take another combination B1, B3. Now if you compare the column values of B1, B3, then 8, 1, B1 is higher. 3, 4, B3 is higher. So none of the column is not dominating another column. Now take another combination of columns, that is B2, B3, then 15, 1, B2 is higher, minus 1, 4, B3 is higher. So here also none of the column is not dominating another one. So now in those situations, what we will do means, just like the rows, here also we are going to add we are going to take the average of any two columns, and that is going to be compared with the another column, and which column values are lower we are going to keep that one, and which column values are higher we are going to eliminate that column. So like that we are going to proceed in the column dominance. So now I am taking the average of column 1 and column 2. So if you take the average of column 1 and column 2, then 8, 15, average is 15 plus 8 is 23 by 2, that is 11.5. 3 minus 1, average is 2 by 2 is 1. So here it is 11.5 and here it is 1. So if you compare 11.5 with 1, 11.5 is higher. Here it is 1, 4, then 4 is higher. So the average is not completely dominating B3. So this combination will not work out. Now take another combination of columns B2 plus B3 average I am taking, and I am going to compare it with B1. Then 15 plus 1 by 2, 8, minus 1 plus 4 by 2, 1.5. Then here it is 8 and here it is 1.5. So compare with B1, 8, 8 equal 3, 1.5. 3 is higher. So that means B1 is dominating B2 plus B3 by 2. So here a possible workout we have existed. So let us proceed. 15 plus 1 by 2. 16 by 2 means 8. Next, minus 1 plus 4 by 2. That means 3 by 2 means 1.5. So now if you compare 8, 8, both are equal. 3, 1.5. B1 is higher. So B1 is completely dominating B2 plus B3 by 2 values. So here B1 column values are higher. So that's why we are going to eliminate B1. So now let us write the same. B2 plus B3 by 2 is greater than or is less than or equals to B1. So as B1 values are higher, we are going to eliminate B1. B1 is eliminated. Then what is the reduced payoff matrix? As we are going to eliminate B1, so writing only B2 and B3. So this one is player B. And next, player A, A1, A2. So now write the column values B2, B3, 15, 1, minus 1, 4. So these are the combination of values. Now let us go for next iteration. So check for row dominance. If you check for row dominance, A1 and A2, 15 minus 1, A1 is higher, 1, 4, A2 is higher. So the column dominance will not work out. And again check for row dominance will not work out. So check for column dominance. So now compare B2, B3 columns. 51, B2 is higher, minus 1, 4, B3 is higher. So here also none of the columns is not dominating another column. So this column dominance will not work out. So here the combination of any two rows with another row is also not work out, as we are having only two rows. And here also the combination of two columns with comparing with another column is also not work out, as we are having only two columns. So let us solve this problem by oddments method or algebraic method. So now let us find the oddments in a row case and also in column case. So if you write the oddments, the difference of 15 and 1, 14, I am going to write it here. The difference of minus 1 and 4, the difference is 5. So I am going to write it here. Right? Next, the difference of 15 and minus 1, 16. I am going to write it here. And the difference of 1 and 4 is 3. I am going to write it here. So now let us find the probabilities. So here without any steps I am writing. Now for player A I am taking. So for a strategy A1, the probability of selecting is P1. So that equals to A1 augment 5 by sum of augments 5 plus 14. So that equals to 5 by 14 plus 5 is 19. Next, now for A2 let us find the probability. So that is P2 equals to, so for A2 augment is 14. So 14 by sum of augments 5 plus 14. That equals to 14 by 5 plus 14 is 19. So what about the strategies of player A? So player A strategies A of, as we are having only two rows it is given in the problem, so I am writing P1 comma P2, that equals to A of, what is P1 value 5 by 19 and what is P2 value 14 by 19. Now let us find the probabilities of player B. So for player B, here we are having the strategies P2, B3 only. So let us find Q2 and Q3. So if you take Q2 and Q3, so for B2 it is Q2 and that equals to, so what is B2 augment? 3 by sum of augments is 3 plus 16, 19. So 3 by 3 plus 16, that equals to 3 by 19. So similarly take B3. So for B3 the probability will be Q3, that equals to, so what is B3 augment? 16 by 3 plus 16 is 9. So write it 16 by 3 plus 16, that equals to 16 by 19, right? So now if you consolidate the probabilities of player B, as player B is having 3 strategies, I am writing Q1, Q2, Q3. So write that those B of Q1, Q2, Q3, that equals to, as B1 is eliminated in the reduced matrix, that will be 0. So what is B2 probability? 3 by 19. And what is B3 probability? 16 by 19, right? And finally let us find the value of the game. Value of the game is represented by with V is equals to, then find the value of the game. Now I am going to find the value of the game with the help of this column. Then 1 into 5 plus 4 into 14 by 5 plus 14. So I am writing that one. 1 into 5 plus 4 into 14 by 5 plus 14, that equals to 5 plus 14 into 4, 56 by 5 plus 14, 19. So that equals to 56 plus 5, 61 by 19. So this one is the value of the game, and these are the probabilities of selecting the strategies by player A and player B. As the value of the game we are having positive value, so that's why player A is going to win the game by 61 by 19 points, right? So I hope you understand this problem. If you understand it, please like this video and also subscribe to the channel and share this video. Thank you.